What do we say? What's a good test statistic to use? Or what's a good data value to use? Are IQs being lowered? Are IQs being lowered? Remember what Jack said too. I mean, it's hard to look at this and say IQs are being lowered. Some of them have been raised. If a company like Subway was in charge of selling 2x4s, for the extent of smacking people over the head to raise IQs, they would gleefully point to the 124 on there and go, look, 124. The IQ used to be 100, now it's 124. That's more than one standard deviation above average. It's 1.5 standard deviations above average. Here's my 2x4 with a special...
Are we supposed to have something else here?
No, that's left over from my 243 class. They're going to show you the outlier of 124 and go, look, IQ is raised. Much like they show Jared and say, look, eat our sandwiches, lose weight. And then at the bottom, the result's not typical. So what do we look at? What do we look at? We have 61 data points. What do we look at, friends?
T-score.
T. Why, Will? I vote for a T-score. What is T? Remember that? Help me, Will, go.
For continuous data when you're finding the average.
Think back, thank you, perfect. Think back to when we were forming confidence intervals around statistics. We'd start with a center and put wings on that center. And there were two kinds of intervals we did. We used the Z distribution, when we had binomial data. Very easy, 1.96, 2, things like that. And then we used the T distribution, the Guinness Corporation's distribution, when we had continuous data. We have continuous data again, and we are once again going to use our T distribution. The name of this bad boy is called the T-test, and we'll come into him in a second. But before we jump right to the T-test, which I do want to get to, I do want to jump to, my question is this. What should we be looking at in that data to decide if IQs have been lowered? What should we be looking at in that data? The data is average. Absolutely, Daniel. Thank you. So real quick, we'll do this one time. I'm going to run 1 bar stats on L1. We're going to run 1 bar stats on L1. Count 1 bar stats. Just L1, so I can just press enter. Okay, here. That's my data's average. 95 points-ish. 94.5 points-ish. That's below 100, yes? That is below 100. So over on my curve over here on my curve, I know that that 94.5 is left of 100. My question is what? I know it's over here.
How far?
Maybe say it again, please.
How far?
How far left of 100? And quick way to individuals say it's 5.5 points away. To which I restate Mimi's question. How far? 5.5 points is a raw distance. How far implies how many what? How many standard deviations away is 5.5? If 5.5 spans more than, say, 2 standard deviations, that's unusually low, isn't it? That's unusually low, isn't it? You can say yes, because it is. It is. You've gone too far south. So now the question is, you might look up here and go, oh crap, look, standard deviation's 9.5, which means 5.5 really isn't all that far down, is it? Except, what are you ignoring when you look just at that 9? You're ignoring something very important.
Sample size.
The sample size. That standard deviation right there means that on average, there are 9.5 IQ points, plus or minus, from the average of 95. But that's only within that sample. You are not allowed to use that out in the world when you try to apply that sample to an inferential thesis like we're doing right now. We have to adjust that. We have to adjust that number by using the central limit theorem. So the true standard deviation is not 9.5 or whatever it is right there. It's 9.5 divided by the square root of 61. Now some of you are sitting back going, oh my God, why is he talking about square roots? What the hell, it's 9 o'clock in the morning, he's busting a square root. Why am I talking about square roots? Because what's it tied back to? The square root of the sample size is tied back to our good buddy from 243 at the very end of 243. I'm not sure if Don does in 243 or not. I'm actually kidding. 3 words! Rise with ventral imit birum. Yes! You have to. These are the jokes, kids. You have to adjust the standard error. Excuse me, you have to adjust the standard deviation, as Drew correctly said, and make it a standard error by dividing by the root of the sample size. So the standard error that's represented in this sampling distribution isn't 9.49 or 9.5. It's that divided by root 61. Now, I'll do this really quickly, because the TI does it all for us automatically. Yay us. But if you take that standard deviation of the sample and divide it by the square root of 61, that's actually the standard error of your average estimate. When you realize that is what effectively is acting as your standard deviation, Mimi, let's answer Mimi's question, or Mimi's statement. She said, how far away from average is 5.5 down? Pretty damn far down, huh? If your standard error is only 1.2 points, you're going 5. You're traveling 3 standard deviations at least. If not, you see what I'm getting at here, friends? Yeah, 9.9 is impressively, whatever, it's gone now, it's somewhere up there. This 9.5 that it was is impressively large, and therefore 5.5 is nothing compared to it. But we're not comparing the 5.5 to itself. We're comparing it to the sampling distribution that traps the population proportion, or the population average, which is centered on 100. That means our estimate has a much tighter standard error, as we evidenced in the central limit theorem back in 243. How are we feeling about these IQ scores? Are they significantly lower? They sure as hell look like it, don't they? They sure as hell look like it, but here's the question I have. And we'll come back after a break and talk about this. Actually, this camera should be somewhere around here. There. Here's the question I have. The standard error is at 1.2-ish. So it's pretty narrow. It's pretty narrow. 5.5 is definitely down pretty far. The only question I have is it down far enough? Now, when you look at it from 3 standard error point of view, you're like, oh my god, it's ridiculously down. It's down ridiculously far. Yes. But the question is, if you actually have to generate a p-value, to give a value of a p-value, besides just less than 5%, and give a value of a test statistic, you need to rigorously apply that standard error and your average of 94.5 to that curve. And that curve is a t-curve. And do you remember anything about t-curves? Are they always the same shape? I mean, well, let's take that back. They're always the same shape. They're always bell-curved. Do they stay static like a normal distribution? They do not. They change with sample sizes. That's where technology is our friend. And we'll run the t-test in the machine as soon as break's over. Go ahead and take 5. Go ahead and take 5. Get some air, get some water. Yes, get some air, get some water.